Dear students, we are discussing second order homogeneous linear differential equations with constant coefficients. Today we will discuss something about operational calculus. Before that, we will see what is operators, what are different types of operators, in particular what is a differential operator. Okay. Now, operational calculus means the calculus of operators. That is, the different techniques and applications of operators. So, what is an operator? Simply, an operator is a transformation which transforms a function into another function. That is, there is a function as an input, there is an operator, and there is an output after applying this transformation on to the given input function. Okay. So if from this figure, if f is the input and t is the transformation and the corresponding output is t of f. Okay. Now, as an example, differential operator, we shall denote it by capital D equal to d by dx. Okay. Now, a differential operator transforms a given differentiable function into its derivative. So, if f of x is the given differentiable function and capital D is the differential operator, then d of f of x means d by dx of f of x, that is f dash x. Here, input function is f of x, output function is f dash x. So, capital D transforms a given differentiable function into its derivatives. Okay. Now we shall denote capital D equal to d by dx. Therefore, dy means dy by dx. That is our y dash. So d square y means second order derivative. That is d of dy. That is d square y by dx square. That is our usual y double dash. For example, d of sin x is our cos x. D square of sin x means what? d of sin x, that means d of cos x, that is minus sin x, etc. We can easily find out the higher order differential operators. Now we can have identity operator. You know what is an identity function? Operator is just like a function. Okay, we define the identity operator I by I of y is equal to y for all y is equal to some function of x. Okay. That means we are getting the same image as the what is the object. Okay. So what is I square? As in the previous case, d square equal to d. D square is d of y. That d square of y means d of y. So I square means what? I of y. That is I of y. That is y itself. So in general, I raised to n, if you take any positive integral power of I, it is equal to I itself. Now we will see what is a linear operator. We shall denote it by L. It is the first letter for linear. Okay. An operator L is called linear if it satisfies the following condition. That is L of a into f of x plus b into g of x equal to a into f of x plus b into g of x for all f of x and g of x, for all functions f of x and g of x, and for all constants a and b. For example, our second order linear differential operator capital L, we can write for a homogeneous linear ordinary differential equation y double dash plus ay dash plus by equal to 0. The second order linear differential operator will be capital L is equal to p of d, means some polynomial in d, that is d square plus ad plus bi. D square, that means in the from equation 1 it is d square plus ad plus bi. Okay. Now, which is a polynomial in capital D. Okay, d square plus ad plus bi. So instead of y double dash, we have d of I. Instead of I dash, it is d of I, and this expression whole becomes L equal to P of D equal to D square plus AD plus BI. So hence we can write this equation L of I is equal to P of D of I as explained before. Okay. So if you replace y is equal to e raised to lambda x, then the above expression becomes L of e raised to lambda x equal to P of D of e raised to lambda x. Okay, that is d square plus ad plus bi e raised to lambda x. So that is equal to d square. We are replacing d by lambda. So d square equal to lambda square. So the above expression becomes a lambda square plus a lambda plus b e raised to lambda x. Okay. Now lambda square plus a lambda plus b is a polynomial. It's a quadratic polynomial in lambda. We shall denote it as p of lambda. P stands for polynomial. Okay, p of lambda e raised to lambda x. Now p of lambda is what? P of lambda equal to 0. It's a polynomial in lambda. It is our characteristic equation. Okay, lambda square plus a lambda plus p. That is p of lambda equal to 0. So it is equal to 0. Okay. Now p of lambda is a polynomial in lambda. P of d is called the operator polynomial. What is the property of this operator polynomial? This polynomial can be treated as an algebraic quantity. That means in particular we can factor it. That means we can factorize this p of d as if it is quadratic polynomial, we can factorize just like, for example, d square minus 5d plus 6i can be factored as d minus 2i into d plus 3, d minus 3i. Okay, d minus 2i into d minus 3i, that is our d square minus 5d plus 6i. Okay. Now it has very wide applications to solve homogeneous linear differential equation with constant coefficients. Remember that. Linear differential equation with constant coefficients. Now similar operator is one of such operators is what integral operator. Okay, integral operator transforms a given integrable function to its corresponding function. Okay, another operator is our Laplacian operator. We are given a function f of t whose Laplace transform exists, then we shall denote the Laplacian operator by L. So if f of t is a function, L of f of t is the corresponding output. So it is again an operator, Laplacian operator. Now we will see some of its applications. To solve d square minus 25i, the whole thing over bracket, y equal to 0. Here p of d is d square minus 25i. So p of lambda will be what? Lambda square minus 25. Okay. So to solve this equation, what is the first step? We have to assume some tentative solution. So let y is equal to e raised to lambda x is a tentative solution of equation 1. So the corresponding auxiliary equation will be lambda square minus 25 equal to 0. So solving, we are getting lambda equal to plus or minus 5. So we can choose lambda 1 equal to 5, lambda 2 is equal to minus 5, or vice versa. So if I am choosing lambda 1 equal to 5, lambda 2 is equal to minus 5, then corresponding basis will be set e raised to 5x, e raised to minus 5x. And the corresponding general solution, here the roots are real and distinct. Okay, hence the solutions are independent, hence they will form a basis. And the corresponding general solution will be y of x equal to c1 e raised to 5x plus c2 e raised to minus 5x. Now here, if the tentative solution is y is equal to some e raised to mx, what will be the corresponding auxiliary equation? M square minus 25 equal to 0. Okay. So what is our tentative solution depends on that the variable in the auxiliary equation changes. So if e raised to mx is the tentative solution, the auxiliary equation will be m square minus 25 equal to 0. Here it is y is equal to e raised to lambda x is the tentative solution. Therefore corresponding auxiliary equation will be lambda square minus 25 equal to 0. Okay. Now another problem. To solve d square minus 3d minus 40i into y is equal to 0. So p of d is d square minus 3d minus 40i. Okay. So p of d operates on y. So L of y means p of d of y. That is given, equation 1. So as before, we choose the tentative solution as y is equal to e raised to lambda x, and corresponding auxiliary equation will be lambda square minus 3d minus 40 3 lambda d square minus 3 lambda, if I have written 3d, d square minus 3 lambda minus 40 equal to 0, and our corresponding solutions of this auxiliary equations are, it can be factored like this. So lambda will be 8 and minus 5. You choose lambda 1 equal to 8, lambda 2 equal to minus 5. The corresponding basis will be, since the roots are real and distinct, so basis will be e raised to 8x, e raised to minus 5x. So general solution will be y of x equal to c1 e raised to 8x plus c2 e raised to minus 5x. Now, another illustration, to solve d square plus 4d plus 13y equal to 0. So this is an initial value problem. Okay. To solve this initial value problem with the initial conditions y of 0 equal to 0 and y dash 0 equal to 1. So as before, we choose y is equal to e raised to lambda s be the tentative solution. So corresponding auxiliary equation is lambda square plus 4 lambda plus 13 equal to 0. Solving, we are getting complex conjugates as the roots, minus 2 plus root I plus I3 and minus 2 minus I3. You can write as minus 2 plus 3i as well as minus 2 minus 3i. Okay. So the roots are complex conjugates, means corresponding basis will be set e raised to minus 2x cos 3x, and set second one is e raised to minus 2x sin 3x. Now the corresponding general solution will be y of x equal to e raised to minus 2x c1 cos 3x plus c2 sin 3x. Okay, where c1 and c2 are arbitrary constants. But the problem is not over. Why? We are required to find out the particular solution of this problem. Means we have to find the values of c1 and c2 applying the initial condition. So applying the initial condition, we will write what is y of x, y of 0. Y of 0 is given 0, so c1 equal to 0. Similarly, you find y dash x, and substituting x equal to 0, we are getting y dash 0 equal to 3c2. It is given y dash 0 equal to 1, so c2 equal to 1 by 3. So substituting in the general solution, we will get the required particular solution as y of x equal to 1 by 3 e raised to minus 2x. Okay. Another illustration. Now in the previous illustration, the roots are what? Complex conjugates. Now one more problem. To solve the initial value problem, d square minus 4d plus 4i into y equal to 0. So this is also an initial value problem. Given the initial condition, y of 0 equal to 3 and y dash 0 equal to 1. Now, as before, we choose y is equal to e raised to lambda x be a tentative solution. So corresponding auxiliary equation is lambda square minus 4 lambda plus 4 equal to 0. So lambda equal to 2 is a double root. Okay. So roots are equal. So real and equal roots. So the basis will be e raised to 2x, x e raised to 2x. Okay. By using the method of variation of parameter. So corresponding general solution will be y of x equal to c1 plus c2x into e raised to 2x. Here also we have to find the values of c1 and c2, the arbitrary constants c1 and c2. For that we have to apply the initial conditions. Applying the initial condition, we are getting c1 equal to 3 and y dash 0 equal to 1 gives c2 equal to minus 5. So substituting in the general solution, we are getting the required particular solution as y of x equal to 3 minus 5x into e raised to 2x. I hope that you enjoyed this video. You practice similar problems. As an exercise, I have given 3 questions to solve. Okay. First one is an initial value problem, and the second and third are homogeneous linear differential equation with the constant coefficients. First, you have to find the auxiliary equation, basis, and general solution. Okay. For the first problem, you have to find the particular solution. Okay. Thank you for watching this video. May your day be filled with good thoughts, kind people, and happy moments. Okay.